Hi there. There are many methods for determining the position of a ground point, such as rectangular coordinate method, angle intersection method, distance intersection method, polar coordinate method. Each method is suitable for different construction sites. The rectangular coordinate method is suitable for construction sites with building grids or perpendicular axes. The angle intersection method is suitable for construction sites with large and complex buildings or structures where it is difficult to directly setting out to measure distances. The distance intersection method is suitable for construction sites where the site is flat, the distance is short, and the two areas are convenient. The polar coordinate method is suitable for construction sites where the survey points are close to control points and the distance measurement is easy. Today, I will talk about reach out right hand, the polar coordinate setting out. Let's first understand the concept of polar coordinate method. The polar coordinate method is to determine the plane position of the design point on a control point, taking the known direction line as the back side edge, setting out a horizontal angle in the clockwise direction, and setting out a design distance from the survey station in the forward view direction. Then, how to use the polar coordinate method for setting out the plane position of ground points. Let's take a look at the example below. A, B are the known plan control points at a construction site, with coordinates A, x is sub 1 slash sub, y is sub 2 slash sub, and B, x is sub 3 slash sub, y is sub 4 slash sub. P is a corner point of a building with design coordinates P, x sub 5 slash sub, y is sub 6 slash sub. It is required to use the polar coordinate method to set out P point on site based on the known coordinates A and B. Next, I will explain the process of setting out P point in 2 steps. Step 1. Calculate the setting out data, the angle beta between AB and AP, and the horizontal distance d from A to P. Step 2. Carry out the point setting out. Let's start calculating the setting out data. First, based on the known coordinate data of A and B, and the design coordinate data of P, calculate the coordinate azimuth AB of side AB and the coordinate azimuth AB of side AP. Calculate the setting out data using the coordinate reverse calculation formula. Note, when calculating the azimuth of each side, the quadrant to which the side belongs should be determined based on the positive or negative signs of x and y. Then convert it to the actual azimuth. When x is greater than 0 and y is greater than 0, alpha is located in the first quadrant, with a range of 0 degrees to 90 degrees. The quadrant angle is the same as the azimuth angle, that is, alpha equals r. The calculated quadrant angle is the azimuth angle. When x is less than 0 and y is greater than 0, alpha is located in the second quadrant, with a range of 90 degree 180 degree. After calculating the quadrant angle, calculate the azimuth angle of the line using the formula alpha equals 180 degree r. When x is less than 0 and y is less than 0, alpha is located in the third quadrant, with a range of 180 degrees to 270 degrees. After calculating the quadrant angle, calculate the azimuth angle of the line using the formula alpha equals 180 degrees plus r. When x is greater than 0 and y is less than 0, alpha is located in the fourth quadrant, with a range of 270 degrees to 360 degrees. After calculating the quadrant angle, calculate the azimuth value of the line using the formula alpha equals 360 degrees, r. Then calculate the angle beta between AB and AP using the deduced azimuth angles AB and AP. Then use the two-point coordinate formula to calculate the horizontal distance DAP between points A and P. After calculating the setting out data beta and DAP required from the known point to the setting out point, we can proceed with the on-site setting out. Step 2. Carry out the point setting out. 1. Place the instrument, theodolite or total station, at point A, aiming at point B, to determine the direction line of the known point. Set out the beta angle in a clockwise direction to determine the direction of AP. 2. Along the AP direction, set out the horizontal distance D from point mark point P to determine the actual position of the design point P. I hope that through this lecture, you can master the polar coordinate method, reach out right hand, for setting out the plane position of a ground point. After class, you may finish the hands-on exercises to further improve the understanding of specific operation process of polar coordinate setting out, and complete the post